live, I think.
Wait,
come on.
now
we're live. Okay, so today is 3/29/19. Okay, so what we're going to do is this. It's called Systems of Quadratic Inequalities. Okay, what does that mean? Systems of quadratic inequalities. Okay, so that's the math word. Systems means more than one. Okay, systems means more than one. So in this case, we have two graphs. Okay, systems means more than one. So we have two graphs. Okay, that's what the systems part means. So we're going to graph two graphs on the same graph. Okay. Quadratics means x squared. So we're going to do two x squared graphs on the same graph, okay? And inequalities, well, that's the greater than or less than, okay? So then the inequalities has to do with greater than or equal to or less than or equal to, okay? Now, what I'm going to do is, to make this easier, let's just put them on the calculator, okay? So if we put them on the calculator, then it's going to make it a lot easier to graph. So you guys have your graphics calc, so number one, clear. One of the things I like to do is talk about real quickly about the window. So if I look at the window of this graph, I can make the same window that I want to graph on my calculator. So I'm going 1, 2, 3, 4, maybe -5 to 1, 2, 3, 4, maybe 5, right? 1, 2, 3, 4, 5, 6, 7 to 1, 2, 3, 4, 5, 6, -7. So and scales are by 1. So if I change the window on my calculator to what's on my paper, then it's a perfect fit. Does that make sense? So let's do that. So I go to my window first. Let's do my window. And when I look at my window, I'm going from -5 to 5, scales by 1. My y's, I'm going to go from -7 to 7 and scales by 1. So I go to my window first, window. And let's go -5 to 5, scales by 1, and -7 to 7. Okay? So that the window on my calculator is going to match the window on my graph. Okay? So far so good? Then I'm going to go to y equals, and I have two equations. I've got a y1 and a y2. So I'm going to go ahead and go y equals a -2x squared. And I'm going to graph that. Okay. So I push graph. Okay, it looks like that. Now we don't have to be perfect on these. We just have to get the general shape. Okay. So I'm going to go ahead and I know it's going to look something like this. Again, it doesn't have to be perfect. Okay. There it is.
Oh, -2.
Right. So my calculator. Did you use a negative or subtract? Good question. Go to it. Yeah, you gotta use a negative or subtract. Right there. Okay, got it. Okay, now I've got this graph. Now, we know how to do the next part because it says less than or equal to. So if I'm standing on the vertex and I want to be below it, it's going to be all of this, right? So shade below. Let's graph the other, and the calculator can do it for me. I can go to my y equals, and my second equation, y2, is going to be an x squared subtract 3. Not minus, but subtract 3. There's a difference between minus and subtract, so that I'm going to graph that one. Okay, it looks like that, and I'm going to put that in, but I'm going to be careful on this one because I'm going to do a dashed. I'm going to make sure this is a dashed line. It's going to be dashed because there's no equal sign, so it'll be greater than the parabola, but it will not be equal to it. So the way to look at that, 1, 2, 3, is it going to look like this, and I'm going to have it look like dash, dash, dash. It doesn't have to be perfect, but I'd like it to be at least in the right vicinity. Okay, all right, not too bad. And again, if I'm standing on the vertex and I want to be greater than, I'd shade above it, right? So I shade above it. Okay. Now, since it's a system, what we're looking for is the places where both graphs work. And that's where the shading overlaps, right? So we want to find all the points that satisfy both graphs. That makes sense? I'll say it again. we want all of the points that satisfy both graphs, and that is going to be in this region right in here. Okay, so I'm going to darken this region, darken that, the rest, and that is my solution. Is all. Now there's an infinite amount of points. There really are. There's an infinite amount of points, and that's why we have to shade. You got all the decimals and all the fraction points in between, right? In fact, there's whole bunches of them in here, and that's why we shade, because we cannot list all of these points, because there's decimals and fraction points and a whole bit, so we shade, and it shows region. Okay, thumbs up? It's not hard, is it? We just have to do the homework and try, okay? Now let's look at example 2. Example 2. So the first thing I'm going to do in example 2 is go ahead. My window seems to be about the same. I'm going to go 1, 2, 3, 4. Maybe 5's fine. 1, 2, 3, 4, 5's fine. 1, 2, 3, 4, 5, 6, 7. We can keep probably the same window as we had, right? Probably keep the same window. Go to y equals.
Didn't match it, by the way.
Clear, clear. And I'm going to go 4x squared. I'm going to graph that. Okay, there it is. It's fairly steep because of the 4. So it's going to look here. 1, 2, 3, 4, 4. I'm going to have a dashed. It's got to be dashed. Has to be dashed because there's no equal sign. Okay, dashed. Okay. Now, I'm going to stand on the vertex. I'm going to stand on the vertex, and it says less than, so I shade below. Now below is all of this, right? It's all of this. And even over here, it's still below the parabola. Hard to understand, but really as I'm going up, 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 these points are below me, right? Same thing here. So I'm going up and up, these points are really below it. It seems odd, but seriously, if you're here, these points are below. If you're here, these points are below, right? Okay, now, let's take a look at the other one. So the other one is y equals, and I'm going to do a 2x squared minus 4. Okay, and I'm going to graph that one. All right, so I'm going to start at -4, and it's going to be a solid line. This one's going to be solid. So we're going to -4, 1, 2, 3, 4, and it's twice as tall, so it's going to look something like this. Okay, and my graph looks something like this, solid line. Okay, and I'm just letting the calculator do the graphs for me, which makes it easy, right? So I need to graph it, so I stand on the vertex, right? If I stand on the vertex, and I shade above it, okay? So it's, no, I didn't, I'm wrong, showed below it. Less than, so I shade below. So I shade below, okay? Shade below, shade below. Now, what I'm looking for is where they overlap. So there's a small little region in here. See the small little region in here? Where they don't overlap. So that doesn't get included. So what's going to happen is you're going to have all of the outside is where they overlap. Okay, that's kind of weird, but it doesn't include this tiny little strip of pink or this tiny little strip of pink, but it outside of the further down graph. It's the outside of the 2x squared minus 4. Okay, this is not hard. All you can do is push buttons, right? Push buttons, but you have to know where to shade, right? Greater than you shade above, less than you shade below. Okay, not bad. You guys agree? Okay, you ready to turn the page? Okay, all right. Now, let's take a look at example 3. So I'm going to go to y equals. I'm going to clear out that one. I'm going to clear out that one. Am I going too fast? Am I okay? Am I good? All right, now I'm going to put in a negative. Now there is a difference between a negative and a subtract. Negative, right? Negative, girls, negative x squared subtract 1. So it's a negative and a subtract. You see this? It's a negative x squared subtract 1, okay? I'm going to graph that. All right. I'm going to make it a solid line because of the equal. Solid line. And I'm going to start at -1. 1, 1, 2, 1, 2, 3, 4. Okay, there it is. If I need to shade it, I stand on its vertex, and it says less than, right? So less than a shade below it, which is inside the parabola, okay? Less than a shade below it, which is inside the parabola. Pretty easy, isn't it? Okay. Okay, then finally on the last example, I can let my calculator do it. I can go y equals, put that one in as an x squared plus 5, right? And graph that one.
Below it.
A shade above it.
When you can't.
Right, you're ahead of me. I like that. Isaac, good job. So I start up at 5, and this one's going to be a dashed line because there's no equal. 1, and it's going to look something like this. Yeah, go ahead and answer it. Okay.
You can't see.
Okay. And we're going to shade, stand on the vertex, right? And it's got to be less than, okay? Oh, I'm sorry, greater than, my bad. Greater than, so I shade above. Now, in this case, this one's kind of weird, isn't it? Do they overlap anywhere?
No.
So they have absolutely nothing in common. So there is no solution because you have to have some points in common. You don't have any. There's no points in common, right? Seem pretty easy? Well, let's look at our journal. And I think that this ought to be a pretty easy assignment for Friday before spring break, right? Well, let's look at our journal real quickly, okay? Okay, let's go to page 172, okay? 172.